In this lesson, we're going to cover the basic data structures that exist in MongoDB. We're going to start with databases. Databases are the top-level containers for collections of data. Many of the commands we're going to run in this course are run against a specific database. For example, db.createCollection creates a collection on the chosen database. The db here represents the database we want to run this command against. We can also create and drop users, or run commands that affect the configuration or behavior of our database. If you're coming from a SQL environment, you're used to keeping your data within a table, where each database has multiple tables. In MongoDB, data is stored in collections instead, and each database can contain multiple collections. So an interesting aspect of collections and databases in MongoDB is that they're created implicitly. This means that when a command that writes data is run against a collection or database that doesn't exist yet, MongoDB will create them for us. Here I've written use brand new DB. Use is a keyword used by the Mongo shell to specify a database is active. And if we run this command, we can see that we're now using brand new DB. But if I take a look at the databases, brand new DB isn't in our list. This is weird, right? Well, this database doesn't contain anything yet, and the use command doesn't write any data. While this database doesn't contain any data, it won't show up in our list of databases. So this is just a simple write command to a collection called new collection, and the DB here refers to brand new DB because that's our active database. So we can see our write was successful because we inserted one document into the collection new collection. We can check our databases again, and we see that brand new DB now shows up because it has a piece of data in it. We can also see that new collection has also showed up on our list of collections because this document is contained in that collection. So now we're just going to cover indexes very briefly. Bear in mind that this is only an overview, and a more in-depth explanation of indexes can be found in M201 MongoDB Performance. Right now, we're just going to say an index is a special data structure that stores a small portion of a collection's dataset in a form that's easy to traverse. This supports more efficient queries. For example, when we issue a query to MongoDB, it checks to see if it can use an index to satisfy that query. If it cannot, MongoDB will do a linear search through the entire collection. This is called a collection scan, and it's very slow. For example, if our document is the last document in our collection, MongoDB will have to search through every other document before it gets to the one that it's looking for. Indexes provide an alternative to collection scans by organizing pieces of our data around a specific field or group of fields. So when a query uses one of the indexed fields, we can retrieve results for that query in fewer steps. However, indexes take up space in memory, so we shouldn't create an index unless it supports our queries. In addition to that, each index we add increases the write overhead on the collection, because MongoDB has to update each index in the collection every time we add or update a document. You can find out more about that in M201 MongoDB Performance. By default, MongoDB will always index the _ID field, which is a required unique field in every MongoDB document. All other indexes are our responsibility to create. So just to recap, in this lesson we covered databases and collections, said a little bit about the MongoDB document model, and briefly covered indexes.